Hey fifth graders, the past couple of days we've been working really hard on modeling mixed numbers and improper fractions. We're going to do a little bit more modeling so that we can come up with a shortcut for ourselves so that we can very quickly convert mixed numbers into their improper fractions that they're equivalent to. So let's talk about mixed numbers first. What do they mean? Well, they are a mixture of whole numbers and fractions. So it's when you have some whole things and then some. So therefore, the value of a mixed number is always greater than at least 1. So you have to have at least one whole thing and then some to be considered a mixed number. So for instance, we have 5 3/4. Well, that's 5 whole things, whether it be 5 cookies, 5 sandwiches, 5 pizzas, 5 hours, and then 3/4 of another. So it could be then 3/4 of an additional hour. So close to 6 hours, but not quite. We have 114 1/3. Well, that means I have 114 whole things. Again, that might be 114, I don't know, cups, or 114 sandwiches, cookies, whatever you want, 114 of those things, and then 1/3 of an additional one of those things. So let's go ahead and take a look at some of the models for mixed numbers and see how that may be helpful for us with our shortcut. So when we're modeling mixed numbers, it's important that we break up all of our whole units into the number of pieces indicated by our denominator. Remember, our denominator is what tells us how many pieces our whole thing is broken up into. So for our first example, we have 3 1/2. Well, 3 1/2 is comprised by one whole thing plus another whole thing plus another whole thing plus half of a thing. Okay, so that's what we call expanded form. So let's go ahead and break up our let's break up all of these whole units into halves, because we're dealing with 3 1/2. And then let's shade in 3 of these whole things. That's one whole thing, 2 whole things, 3 whole things, and half of a thing. So this was 2 halves, this was 2 halves, this was 2 halves, and this was just 1 half. And this gives us a grand total of 7 halves. That is the improper fraction equivalent to 3 1/2. Let's take a look at another example. We've got 2 3/4. Well, that's one unit plus another unit plus 3/4 of another unit. So let's go ahead and break up our units into quarters. So let's break it in half and cut our halves in half. That's a really easy way to cut things up into quarters. Cut it in half, cut the halves in half. Now let's shade in 2 whole things. So here's 1, 2, 3, 4/4 was equal to one of those whole things. 4 more gives us our second whole thing. And now 3/4. Well, that gives me a grand total of 11 quarters, because 4 plus 4 is 8 plus 3 is 11. And you can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 quarters is what we just modeled. Let's take a look at mixed numbers on number lines. So remember that mixed numbers live between 2 whole numbers. So it's really important that we figure out what those 2 whole numbers are. And there's a pretty easy way to determine what 2 whole numbers your mixed number lives between. They live between the whole number part of the mixed number you're dealing with and one more than the whole number part of that mixed number. So for instance, let's go ahead and just kind of look at the bottom. So we'll kind of get ahead of ourselves here. 4 2/3. So I have 4 whole things. So it does live between 4 and then a little bit more. So we're going past 4 whole things. We're getting closer to 5. So it lives between 4 and 5. If we take a look at the next example, we've got 7 2/3. Well, that's going to live between 7 whole things, because you have 7 whole things and then some. So we're getting closer to 8. So that lives between 7 and 8. And now let's talk about how we would graph those on a number line. Well, those two whole numbers that they live between is super duper important. We definitely need those two numbers showing on our number line. Then what we're going to do is we're going to break up that unit from, 4 to 5 or from 7 to 8. Those are both units because they're a distance of 1 away. We're going to break up that unit into whatever number of parts we need as indicated by the denominator. And as you can see, the denominator is really important. So we know that 4 2/3 lives between 4 and 5. I'm dealing with thirds, so I need to cut this up into thirds. So I like to put my finger in the middle when I'm creating thirds, and I go a little bit to the outsides of my fingers, and that usually creates my 3 equal parts. So this is 4 1/3, 4 2/3, and technically this is 4 3/3. Let's ask ourselves if that makes sense. Well, yeah, 3/3 is one whole thing, so 4 plus one whole thing is 5. Those two live in the same spot. So let's go ahead and plot where 4 2/3 lives, right there. Let's look at this next example. We have 7 2/3. So again, we know it lives between 7 and 8. We have a distractor on this number line. We care about 7 and 8. This is one unit. This is the unit that we care about. So we're going to take this one unit and we are going to break it up into 3 equal parts. So again, I like to take my finger, I put it in the middle, and then I put my tick marks to either side of my finger because that usually breaks it up into 1, 2, 3 equal pieces. So this is 7 1/3, 7 2/3. So 7 2/3 lives right there. Okay, so now that we know how to model mixed numbers, let's talk about how we can convert them into improper fractions. And a lot of you are probably like, why do we want to turn mixed numbers into improper fractions? Well, when we start adding and subtracting mixed numbers, improper fractions can help us, and specifically, or more importantly, when we start multiplying and dividing mixed numbers, improper fractions will be our friends. So it's really important to know how to convert between the two. So let's take a look at 3 5/8. Let's break this up. Well, 3 5/8 is equivalent to one whole thing plus another whole thing plus another whole thing plus 5/8 of a thing. So let's create eighths. I'm going to create quarters first and then cut it in half, and I'm going to go sideways with my cut. It's a little bit easier. So I'm going to cut this in half, cut my halves in half. That just created quarters, and then if I cut quarters in half, I've doubled the amount of pieces. I now have 8. Let's do that to all of my units. Okay. Let's go ahead and shade in 3 5/8. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 eighths makes up this one whole thing. One whole thing is made up of 8 eighths. That's really important because this is what's going to help us out with our shortcut. So I know if I'm going to fill in another whole thing, I'm going to have another 8 pieces because I'm dealing with eighths. Here's another set of 8 eighths. Here's another set of 8 eighths. And now I have 5 eighths left. 1, 2, 3, 4, 5. 5 additional eighths. So here's my one whole thing. That was 8 of them. Here's another 8 eighths. Here's another 8 eighths. So those are my 3 whole things. So instead of counting them up individually, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, we can go ahead and use a shortcut. We can use our math reasoning skills. So if we know that one whole is equal to 8 eighths, well then 3 wholes is 3 times that amount. So we're going to go ahead and take 3 times 8, and we get a total of 24 eighths. 8 eighths, 8 eighths, 8 eighths, that's a grand total of 24. 8 plus 8 plus 8, that's repeated addition, that is multiplication. And then how many additional eighths do we have? So here's our additional eighths, additional, adding, and I'm really emphasizing that because adding and multiplying are a really big component of our shortcut. We have 5 more eighths. So that gives us a grand total of 24 eighths in our whole number component plus 5 more, which is 29 total eighths, or we could say 29 eighths. Now this is a huge part of the shortcut. So the shortcut is that what we're doing is we're multiplying. This was my whole number, right? Because I started out with 3 5/8. This is my whole number times the denominator, and to that we added the numerator, and that is the shortcut. You take your whole number, you multiply it by the denominator, and then you add your 5 extra pieces, which was the numerator of your mixed number. And that's the shortcut down here. So let's summarize that. So our shortcut is that we multiply your denominator by the whole number piece. Then we add the numerator. We are going to keep the denominator the same because we started with eighths and we still have eighths. We're not changing the sizes of our pieces. We're not changing the number of pieces. We were dealing with eighths, and our final answer, when we counted up all of these total eighths, we still have 29 eighths. So we're going to keep that denominator the same. So here's our little shortcut for ourselves. We're going to say times E plus E. Times for multiplication, plus for addition. And that might help us to remember the shortcut. So we're going to kind of map out 2 more examples, and then we'll just go straight for the shortcut. So if I need to convert 2 3/4 into an improper fraction, what I'm going to do, so I know that 2 3/4, that's 1 whole thing plus 1 whole thing plus 3/4 of a thing. I'm talking about quarters, so this is 4 quarters plus 4 more quarters plus 3/4. That's a grand total of 11 quarters. And if I had used my shortcut of times E plus E, then I've got 2 times 4. Oops, 2 times 4 is 8, plus 3 is 11, and I keep the denominator the same. 4 3/10, well, that's 1 unit, 1 unit, 1 unit, 1 unit, plus 3/10 of a unit. So this is going to be 10/10 plus 10/10 plus 10/10 plus 10/10. Well, that's 4 sets of 10/10, which is 40/10. This is that 4 times 10. And then to that, we're going to add the remaining 3/10, and we get a grand total of 43/10. That's our answer. Let's see if we had used our shortcut of times E plus E. We have 4 3/10. I'm going to go ahead and multiply, then add. 10 times 4 is 40, plus 3 is 43/10. We got the same answer. This is a much quicker way to get to that answer. So let's do a couple more examples together. I'm not going to do any modeling now. I'm just going to go ahead and, in a couple of seconds, generate the improper fraction. So I'm going to go ahead and multiply and add. 2 times 7 is 14, plus 1 is 15. That's equivalent to 15 halves. Times E plus E, that's 20 plus 3 is 23/4. Multiply and add. 64 plus 5 is 69. I keep my denominator the same because I was dealing with eighths. I still have eighths. And 10 1/3. That is equivalent to 31/3.